Good morning, students. Welcome to lesson 3. Before we dig deep into the life cycle of stars, I wanted just to remind you what you've investigated and where we're going in our unit for astronomy. So you guys started this unit looking at a plethora of vocab words. You had to classify these words. You had to put these vocabulary words into like groups. From there, we started investigating what is the universe, what is the scope, and what is the size of our universe. Then we kind of broke it down even farther into the concept of stars. First, we looked at star constellations. Yesterday, you watched a group of videos where you were collecting and analyzing evidence and learning how to synthesize that evidence into a well-constructed summary paragraph. Today, we're going to dig a little deeper into the life cycle of stars. But instead of watching videos, you guys are going to read an article today. And when we read, we need to leave tracks of our thinking. We call that text coding. When we text code, we are annotating the text. I want to know, what do you already know about the life cycle of stars? I want you to tell me what is new learning, what vocab words need clarification. I want to know what is exciting or interesting, or what connections do you have? So I'm going to model showing how we text code and how we leave these tracks of thinking as we annotate an article for just this first paragraph on star birth and life. I'm going to read through the paragraph first, all the way through, and I suggest you do the same, paragraph by paragraph, sentence by sentence. Read it all the way through and then go back and annotate. Leave those text codes so I can know what you are thinking as you read. Okay, so here's the first example. Imagine an enormous cloud of gas and dust, many light years across. Gravity, as it always does, tries to pull the materials together. A few grains of dust collect a few more, then a few more, then more still. Eventually, enough gas and dust has been collected into a giant ball that at the center of that ball, the temperature from all the gas and dust bumping into each other we call friction, which is under a great amount of pressure of the surrounding material. The center of that ball reaches 15 million degrees or so. A wondrous event occurs. Nuclear fusion begins and the ball of gas and dust start to glow. A new star has begun its life in our universe. Okay, so I'm going to go through and I'm going to text code, and I'm going to use some of our Cami features on the side. The first thing I'm going to do is I'm going to go through, I'm going to mark up, and I'm going to highlight some vocab words, whether they're vocab words that we've already learned, we've already discussed, or we've already investigated, or maybe these are vocabulary words that need more clarification. Highlight them. Keep track of important words. So, imagine an enormous cloud of gas and dust, many light years across. I'm still a little confused on light years. I'm going to highlight it. Gravity seems like a pretty important word. As it always does, tries to pull the materials together. A few grains of dust collect a few more, then a few more, then more still. Eventually, enough gas and dust have been collected into a giant ball that at the center of the ball, the temperature. We've talked a lot about temperature as it relates to weather, but we're going to start making connections with temperature as it relates to color in stars. Okay, so I'm highlighting temperature. Okay, so we know that the temperature is increasing from all the gas and dust bumping into each other under the great pressure from the surrounding material. I'm going to use my drawing feature, and I'm going to change it red. I'm going to change it so it's not so thin, maybe to 1 point. And this idea right here of bumping into each other, I'm going to make my connection symbol. This reminds me of a vocab word we've discussed. Things that bump into each other, they run into each other. There's going to be an increase of temperature because of friction. So I'm going to make my connection symbol, and then I'm going to add a text box right underneath, and I'm just going to type friction. Okay, keep going. So we know that the center of that ball is going to reach about 15 million degrees or so. A wondrous event occurs, nuclear fusion. If you guys read the directions, I gave you this phrase. You also saw it yesterday in your Ed Puzzle video. Nuclear fusion is the reaction that creates the first stars. Okay, and we know that nuclear fusion begins and the ball of gas and dust, they start to glow. Okay, we've also talked about this, the glowing, the lumosity is a type of energy. So again, I'm going to go back to my drawing and I'm going to draw my connection symbol, because this right here, this glowing text box, it reminds me of radiant. Ooh, I don't want it yellow. We want it to be black, radiant energy. And another word for radiant, I might put a colon, is light. I'm just going to move this over so it's easier to see. Okay, keep reading. And we go, nuclear fusion begins and the ball of gas and dust start to glow. A new star has begun its life in our universe. Again, if you read the directions from me at the very beginning of the direct instruction, I told you that the first phase that a star goes through is called a protostar. So I'm going to do another connection because this reminds me of something Ms. Lang has already taught me. Text box right here, turning this black. This is called a protostar. I'm going to change this black because then it looks better. Okay, you're going to go through this entire article where you are highlighting vocab words, you're showing me connections, you're adding in necessary information. But one thing I forgot, let's go back to the drawing. Imagine an enormous cloud of gas and dust many light years across. Gravity, as it always does, tries to pull the materials together. I already knew that gravity is pulling things together, okay? This is a force. So I'm just gonna put a check mark right here because I know that, okay? Blah, blah, blah. A few grains of dust collect a few more, and then a few more, then more still. Eventually, enough gas and dust has been collected into a giant ball that at the center of the ball, the temperature reaches about 15 million degrees. I'm gonna put a star over the top because that is impressive. We might be looking at that on a quiz about how much the temperature increases due to the friction and the immense amount of pressure that happens at the center of those stars. So you are going to go through, this is paragraph 1, I did it for you. Paragraph 2, move on to 3, and then paragraph 4, and this is where you're going to start to get into some new vocab. Okay, look at section 2, the beginning of the end, all the way here through the end, okay? And then I want you just to stop when you get to the end of neutron stars, okay? Take your time, text code, read. You are going to use those vocab words for your independent practice today. Have fun.